Okay, sure. Yes. So, yeah, good evening, guys. And chalo, start the cameras fast. Okay, chalo, so in the last session, we discussed the basics about this electromagnetic waves and all the simple formulas. Right? We'll solve some questions also today about this. So for this Maxwell's equation, there were four equations like this, right? And using this, some concept, some points, or we can say result of Maxwell equation, or you can say properties of electromagnetic wave, whatever, right? So first we said that there is electric field and magnetic field, right? Then this is the important formula we need to use many times in the problems, right? Then here this one is important, C or B we can say, right? So accordingly, we also have solved some questions. So let's check. What is remaining? This whole thing is done. So now almost the theoretical part, the small simple theoretical part is remaining. That is the electromagnetic spectrum, those X-rays, gamma rays. That's very simple actually, all theoretical. But before that, we'll solve some questions which are previous year questions, obviously. Okay, so let's solve. Last question we did was this one. So now let's solve the question. Screening, guys. So this question is J main 2020, right? So last year's question. P is given. E into 10 to 2 minus 8 sine 200 pi y plus ct, and this one is, what is this? This is J-cap, right? So B bar is along the J-cap, right? And they are asking you the E bar. E bar is equal to question mark. So I'll write the options. You start solving this. No. Sanjana, no. No. Okay, so remember our formula is this. Formula is E bar cross B bar is equal to S bar. Now this is not a problem, right? So I guess everybody can get this E naught. So this is your B naught, right? And what we know that E naught upon B naught is equal to C. So you can say E naught is equal to B naught into C. So E naught will be 3 into C is 3 into 10 raised to 8. And this is 3 into 10 raised to minus 9. That's correct. So sorry, minus 8. So answer will be 9. So E naught is 9, that is correct. So you can say this is wrong, this is wrong. But the problem is with the all the vectors, right? So remember, we talked about this already. So sine, let's say omega t minus k, this is our basic original wave, right? This wave we say it is along the positive x axis. Positive x axis, right? So S bar, I can say S bar is along the I cap. Okay. Now our wave is something like this. Sine 200 pi y ct something, right? So ct, or we can say this is 200 pi, or doesn't matter anyway. So just focus on this y, right? So this is t factor is here, that 200 pi is also there. Don't worry about that. The t factor, t variable is here plus y. So I just replace that, right? So it will look something like this. Now what I can say that this wave is along the y-axis, right? And it is not positive, it is negative. So negative y-axis. So your S bar is equal to S bar is in the J cap terms, we can say. Okay. Now let's substitute here. So E bar is sorry, negative y, so minus J. Minus J cap. Substitute here. So minus J cap into B bar, where is B bar? B bar, okay, sorry, something is wrong. B bar is wrong, I guess. Baby is minus J. Okay, this should be I cap. This is I cap. So minus J cap and I cap. Right, so E bar cross B bar is equal to S bar. No, we want to calculate E bar, no? So I told you to write this as cyclic, right? So you can take the S bar on this side. So S bar cross E bar is equal to B bar. Or I can take the B bar on this side. So B bar cross S bar is equal to E bar. So these are the three forms. You want to find out the E bar. So B bar is given. B bar is what? I cap into minus J cap. Right? So I cap minus sign, we can take it outside. I cap cross J cap is equal to K cap. So your E bar should be minus K cap, minus sign inside. So that's it. So therefore, that minus whatever is your answer, it should be in minus K cap here. But that minus sign, we can take it outside. Right? So this will become minus 9 and whole other thing is same. Right? Just like that. Then plane EM wave, it's going along. Let's say I cap plus j cap divided by root with polarization along key cap. Right. So now remember, polarization means what? This wording I have actually, that's why I've taken this question. So when they say polarization means what? This is your E bar. So E bar is along K cap. That's what. And plane EM wave is going means propagation of wave. This is your S bar. So this is S bar. This is E bar. Question is find the magnetic field. Options, I will write the options so you can try. Till then, try to find out the axis, right? So along B bar will be along X cap, sorry, I cap, J cap, K cap, right? So try finding that. So till then, I will write the options here. Question is easy, but simple basic things you need to know about this one. Okay, so look at the option and then you can try solving this. So, Chita, correct. Abdul, no. Inshu, no. Right, so here, what is a new thing that will I will explain? This thing you can try, right? So try this one and try to find out the B bar's direction, right? So for B bar means you have to use this formula. So you have to take the cross product of this is S bar and B bar means along K cap. So B bar is sorry, E bar. E bar is your K cap, right? So we understood the one concept that is polarization here. Now another concept is like this. If the EM wave is along X axis, if I say it is a positive X axis, then normally how we denote it? So this is omega t, or let's say E naught or B naught something. So B naught sine omega t minus kx, right? So x denotes the axis here, means the direction. So they already have given us the direction. So, but it's not positive, right? Take the negative sign. So if it is moving in a positive direction, take the negative sign here, right? So negative, and this is your direction in place of your whole x. So therefore, you can see the x is like this. Now remember, this k is a different thing, right? Propagation constant you call it as, and this is the direction, right? So we need this S bar with the negative sign. So this is wrong, obviously. All others are negative, so that's not a problem. So all others could be correct. then you only have to check this one, this one, this one. So by logic, obviously, I think you can consider that this is wrong, right? So kcap cannot be answered. And then you just have to find out using this formula that S bar cross E bar is equal to B bar. Don't remember all of them. Only remember this formula. E bar cross B bar is equal to S bar. And once you know that, just try to switch it, right? Whatever, now you want the B bar. So write the S bar. Yes, take S bar here, E bar in place of B bar, and here the B bar. That's it. If you want E bar, then replace this B bar into S bar. So let's just put it in cyclic fashion. Okay? So you have to only remember the first one. Other C, this B, and this B should be like this. Okay, sure. Anybody any doubt in this? These are simple questions, and if you see, many questions have appeared in, I guess, almost in every attempt, right? So if there are two attempts, obviously you have the lot of sets there, right? So in every paper there are a question like this, right? In on electromagnetic wave. So tell me if there is any doubt. Can you guys solve this question? So all of these are. This is also the. I've taken the previous year questions only. This was the again 2020 question. JMN 2020. Right. So it's very simple. You should be able to solve this very easily. Right. So any doubt? Yes, Mazin. No. Okay. So let's see the next question. Now, they are saying the electric field of two plane EM waves, right? So electric field of two plane EM waves, electromagnetic waves, are, first one is given like this: E1 is equal to E naught J cap cos omega t minus kx. Then E2 is equal to E naught K cap cos omega t minus ky, right? Sure. So first of all, tell me direction of the first wave is means I cap, J cap, K cap, S bar. S bar is equal to what? Sanjana, correct. Correct. Yeah, what is the direction of the first wave? That is the question. Yes, bar. Ishita, correct. Right? So we know that this is the x, so it is along x-axis. If this is the negative, then we are going to say wave is along the positive x-axis. Means I can. If it is positive, then we are going to say it is negative I can. Sure. So similarly, yes, Inshu, tell me the second axis, second wave's axis. Yes, Inshu. Okay. Y-axis. Positive or negative? Positive or negative? Positive. Correct. So we understood the two waves, where the waves are going. You already know the E bar. E bar you can directly see here, right? C2 is along K cap, E1 is J cap. Okay. After that, the question is, at t is equal to 0, particle of charge q is at origin. Right? So these two waves are there, and charge is also there. Okay. Charge q, which is at origin. Now, it is moving with velocity. Moving with velocity. Who? That charge. Velocity 0.8 c j cap. The question is the instantaneous force experienced by the particle is. They're asking you the force. Now, we haven't done any force in this chapter, but obviously you need the concepts from all the other chapters. Okay, chalo. So now obviously there is a E bar. So you need the force which is used in electric field. It is a QE. right? So two waves, so you can take the two forces. Let's call this as QE1 and another force will be QE2. So you have to add them accordingly, whether they are vector, same direction, like that. So you can add those. Similarly, you can consider the magnetic field also. So magnetic forces you have to consider that. Okay, sure. So magnetic forces Q into V bar cross V bar. Again, two waves are there, two electric field, means two magnetic fields are also there. So magnetic force will be Q into V bar cross V bar. V bar is this one. V bar means V bar of the charge. B bar you have to calculate, right? So you have the E naught, everything, right? So big question. This is a big question. Chalo, try solving this one. I'll write the options. Okay, so let's try this one. So there are two waves. Now we also need the B bar. So first, let's see. Let's write. So for E1, I can say E1 is equal to along the J cap, and S bar is along the I cap. Right. Similarly, this is the first wave. For the second wave, you can see the E1 is along the K cap, and S bar is along the, I guess, J. No, let me verify. Yeah, J. J is here. Now, as I said, remember only one formula. E bar cross B bar is equal to S bar. What you need the B bar. B bar is equal to S bar cross E bar is equal to B bar. Right? Just take this S bar to the other side. That's it. So what I can say using this B bar is equal to S bar cross E bar, means I cap cross J cap. I cap cross J cap means K cap. Similarly, let's call this as B1 bar. This is S1, this is S2. This is B2 bar. Again, S bar cross E bar means J cap cross I cap. J cap cross I cap means J cap cross K cap means I cap. Right? So both are positive. Okay. Similarly, I can say B naught. B naught is equal to what? E naught by C. Here also B naught is equal to E naught by C. Okay. After that, force we want to calculate. Force Fe, let's say. I told you that force Fe is equal to what? Q E1 bar. Right? And here force Fe again is equal to Q E2 bar. So I can say this is Q E naught, right? The whole thing is there, cos and etc. etc. That will anyway we don't have to report that. So Q into E naught. This is J cap, you can see. Q E naught J cap. This is Q E naught K cap. Because you can see E naught is same for both of them, right? Magnitude means maximum or peak value of electric field is same. Okay. So after that, FB. FB means what? Magnetic force. Magnetic force is given like this: Q V bar cross V bar. Okay. Now Q is as it is. V bar means what? They have given the value of V here. This is your V bar. Means with what velocity charge is moving? That is 0.8 C J cap. So you can say 0.8 C. Let's write the magnitude, and J cap I can write here. J cap cross. B bar's magnitude is what? This is the B bar's magnitude. E naught by C. We know the value of CC is anyway going to get cancelled. That's not a problem. And this B bar is along what? Along K bar. So this is J bar cross K bar. Right. So CC will get cancelled. This is 0.8 Q E naught J cap cross K cap is I cap. Similarly, now let's do for the second one. FB formula is same. Q into V bar cross V bar. Q is as it is. Velocity is 0.8 C. It is in J cap direction given in the formula. B bar is what? E naught upon C. And B bar is along which direction we calculated? It's I cap. So CC again CC will get cancelled 0.8 Q E naught J cap cross I cap means minus K cap. That's it. So these many forces are acting on this. 1, 2, 3, 4. Add all of them and find the correct option. These are the options. So, now. Show correct. Correct. Anyway, so this is the one of the variation they could ask in this chapter. So remember, next question, this one. Again, this is everything is a previous year question. This is also 2020 question. Right. So remember, they could also ask that this is simple one, not simple one, but 2-3 concepts are there. We got it clear. Then this you can see, this one was easier one. Then again, this 2021, it was easier one. So some simple questions also they could ask, right? But in this chapter, you can see small formulas are there, right? So you have to worry about those small formulas. Okay. One more small concept is there. Whenever we know that any wave is traveling, it carries the energy, we know that, right? So in this EM wave, we have the two things. One is electric field, one is a magnetic field. Okay. So in what we are going to do, remember, there is one term which is called as a energy density. So energy density. Again, one will be electric energy density. One is a magnetic energy density, right? This you can represent by UE. U means energy density and magnetic means UB. Now, whatever is the energy, whatever is the total energy density, you can say, one concept you are going to remember, that energy is equally distributed between electric and magnetic field. So ultimately you can say this UE is equal to UB. That's it, right? And there was a question in this year actually, JEE in 2021, right, which actually had this answer, right? Question, I will read the question. Question was for EM wave, relation between the average energy density due to electric field and average energy density due to magnetic field are related as, and one option is like this, other one is like this, other one is like this, right? And you just have to select this one, right? So this is how they could ask the questions in G. Very simple questions. Now this UE has the formula. Formula is equal to 1/2 epsilon naught. Epsilon naught means permittivity, E RMS whole square. Similarly, UB has the formula 1/2 B RMS square upon mu naught. Right? So two formulas you have to remember again. As I say, formulas look a little bit complicated in this chapter, right? But questions based on that are mostly easy, right? So we also have the intensity. No? So let's see how the questions will appear on this. that EM wave with magnetic energy density is equal to 1.02 into 10 raised to minus 8 joule per meter cube. Okay. Question is amplitude of the magnetic field wave means you want to calculate B. That's it. Sure. Try this one. Simple question. So directly use the formula. This formula B RMS will be your answer anyway. B RMS or B naught. Okay, try this. We will modify this formula to RMS B RMS B Okay, do one thing, skip this problem for time being. Something wrong with this. Yeah, Ishita, anyway, answer is correct. But at 716 Tesla. That root 2 factor is going to be there. I have to check that. Right, so skip this question right now. But remember this formula, just you can have this formula with you. Let's try this next question. Question is electric field intensity by radiation of 100-watt bulb at a distance of 3 meters is E. Okay, so this is here we are going to get a new formula. So they have given the electric field intensity they are talking about. Okay. Then electric field intensity produced by 60-watt bulb is question mark. Okay. So we need the new formula here. So remember the new formula, that I, that is the intensity. Write the whole thing. Intensity, let's represent it by I, is equal to, let me write it here. Intensity I is equal to power upon area. What is the meaning of this? So for example, this is the bulb here. So if they ask you, they are saying that at distance 3 meters, right? So this 3 meters, what is the intensity? So how to calculate this? So for this intensity, whatever is the power of the bulb, and this is your area, right? Area of not a circle. This is not a circle. In 3-dimensional, it is a sphere. So when we say area, let me write this as a surface area. So we have to take the surface area of the sphere. So intensity is equal to, I can say, power upon surface area of the sphere. Surface of the area of the sphere is 4 pi r square. Okay, so this is what we have to write. But this is the electric field intensity is E. Okay, just a minute. Okay, that E. Electric field. This is our normal intensity. We have to convert that into electric field. So remember, the total intake will be like this one. We know that this formula, 1/2 epsilon naught E RMS whole square. Right? This is the formula for electric density. So if you multiply this by the C, you will get the electric intensity, right? So it's like that. And this is only electric part. We also have to get the magnetic part, right? One more thing here we can understand that electric and magnetic are magnitude wise they are same, right? So I can say total I. Let's call this as total I, total intensity. Total intensity is this one. Now total one intensity will be because of electric plus magnetic. Plus magnetic. This is equal to 1/2 epsilon, 1/2 B RMS square upon mu naught, I can say. But what I know, magnitude wise, these two are equal. So instead of saying separately, I can say, let's say 2 into electric, right? So total will be 2 into electric. So I can cancel this. I don't need this. is equal to what? Is equal to P upon 4 pi R square. Okay. So they are asking about the electric field. So we are interested in this one, ERMS whole square. And power is given, distance, whatever distance is given, distance is same. They haven't changed the distance. 3-meter distance, electric field is E, power is 100. So what is the power is given, electric field we want to calculate, and the distance is same. So we just need the relation between this E and this P. So ultimately, I can also say that ERMS whole square is directly proportional to P. Everything else is constant. 1/2 is constant, epsilon naught is constant, C is constant, 4 pi is constant. R, they are keeping the R same. Sometimes they will say 3 meter, then in second case they will say 6 meter, right? So R they could change. Okay, so that's it. So ERMS square is directly proportional to P. So E1, let's say E1 upon E2 is equal to P1 upon P2. P1 is given as 100, P2 is given as 60. E1 is E, E2 you want to calculate. So it's like that. So I'll write the options, try solving this. Where did we multiply by 2? Okay, so why we multiplied by these two, I will explain this again. So remember, total energy, we said total energy is equally distributed in electric field plus magnetic field, right? So let's say energy due to electric field and energy due to, let's say, magnetic field. Similarly, this total intensity also you can say total intensity will be, let's say, due to electric field, due to magnetic field. And what we know that these two are same, right? They are equal in magnitude. So this also we can say I of E is equal to I of B. So instead of writing this, what I can say, this is nothing but 2 times EB. Similarly, this is 2 times IE. Right? So total intensity is 2 times IE. And how to write the intensity? Intensity and this energy. What is the relation between them? So this is the new formula again. 1/2 epsilon naught E RMS whole square into C. Okay, got it? That's why we have multiplied it by 2.
Yes, sir.
So all the small formulas, make a list of those formulas, and then you can easily solve this type of questions. See, yeah, Azin correct, Ishita correct. Abdul, correct. So remember this formula says about RMS, right? So if they ask you the peak value, then you will obviously need to use the ERMS and E naught relation there, right? So here, that's why I told you to skip this question. That I have to see that whether maybe this could be total energy density, I guess. That root 2 factor will get cancelled somewhere, right? So ERMS and peak value, you know the relation? What is the relation? ERMS is equal to B naught upon root 2. ERMS upon root 2. Okay, anyway, I will check the whole question. Something is wrong with that question. Okay, now let's solve the similar question, which will need, you have to use this formula. So question is, radiation emitted, so we can say bulb is 1000 watt. So power is given. And it generates the electric field and magnetic field at a point. So if this is the bulb, the distance is given. At a point, they are saying at this distance 2 meters. Right. Question is efficiency of the bulb is 1.25%. So very less efficiency, right? So 1.25%. And peak value of electric field at that point, at 2 meters, we can say at 2 meters distance is equal to, they are saying it is equal to x into 10 raised to minus 1 volt per meter, right? Then x is equal to question mark, right? This is a numerical question, right? They don't have the options, right? Whatever is the answer, you have to type it. Okay, so 5 questions are there from every J paper that you have to type the answer. So it will be in integer format, right? Something 5, 10, or 100, 1, 5, something like that. Okay. Sure. So use this formula. Again, total energy, total intensity. So double 2 factor will be there. So exactly this formula. But what is going to change here? That remember, efficiency is given. So whenever we are going to find out efficiency means what? Output power upon input power. So in our formula, we need the output, right? Bulb is giving out the light. So that is your output. So your output power will be eta into your power. So that's it. So wherever is there P upon, we have said total intensity is equal to P upon 4 pi r square, right? Instead of this P, just join that eta also there. That's it. So this is the only difference there, right? So I will write here like this. It's a P output or eta into P upon 4 pi r square. So this is a total intensity. So you need that double factor again. And now solve it. You need the peak value. Peak value means E naught you want to calculate. Chalo, solve this. Show correct. Mm, 96. No. So answer is 137. Is the answer. Right, try this one, even I'm not getting the answer. Let me check if everything is correct. 1000 watt bulb. Yeah. 1000 watt efficiency is 1.25 to 100. That's correct. Total is 2 epsilon naught. V RMS whole square into C. C will go downward, 4 pi epsilon naught will go downward. That is correct. This is 4 is correct. This is 12.5 is correct. So E naught by root 2 means E naught square 2, 2, 2, correct. 12.52 are 25. 9 into 10. Okay, anyway, I have to try this one. Ensure got it correct, I guess. So might be correct. So question might be correct. No problem. So try this one. I will also try this, right? So answer should be 137 should be your correct answer. Inshu, have you got it?
Sir, I took the epsilon value as 8.85 into 10 raised to minus 12, and I took the C value as 3 into 8 raised to 8, 10 raised to 8. So
Okay.
I did that 1.25 by 100 into 1000 by 4 by 2 square is equals to 1 by 2, 8.5. I multiplied it all, then I got E naught square is equals to 187.4. So I took the root into 10 raised to minus 1, so I got 137 after rounding it off.
Okay, no problem. The answer is correct. Okay, I'll check what is wrong here. So anyway, so all of you can check this one. Okay, try to solve this question anyway. So this is how these are the questions. These are the set of questions which have been asked in the. So all the questions are the previous year questions which I have taken in this chapter. So you will get the idea that how the questions could be asked in this chapter, right? So small part is remaining in this chapter, that is that electromagnetic spectrum, the complete theoretical part, right? Not a lot of questions have been asked on this, but if they do ask, those will be most probably it will be easier, right? So anyway, we will do that. Let me find the electromagnetic wave. So this is the whole thing we already have covered. So this is about the displacement current, right? So we have done this. That capacitor, how the capacitor, there is a magnetic field, how needle will get displaced, right? So we have done this here. So this is how they form the displacement current. We already have done this. So this is the whole displacement current. Same thing we have given here. So these are the Maxwell's 4 equations. Accordingly, we have solved the many questions on that. So this is the electromagnetic wave, like Ex and By they have said, right? These are also questions we have covered. So we know this formula, B naught is equal to E naught by C. Then V is equal to 1 upon under root mu epsilon, or C is equal to 1 upon under root mu naught epsilon naught. We have solved some questions on that too. So this is your energy transfer they have given here. So if you remember, we have used the formula that P that 1/2 epsilon ERMS whole square into C, right? So that C they have taken in the denominator. So this is 1/2 that U we already know, right? U is the total energy. So the total energy they have represented it like this U, right? Here you can see that energy density is the energy density, and for this electric field's energy density, similarly magnetic energy density will be like this. So we have covered these two, and those two are similar, right? So equal, they are equal. So total energy they have represented by U, right? So U divided by C, they are saying it is a momentum in this case. Total momentum is equal to U upon C. That's it. So question we have done it like this. So these questions we have done like this anyway. And the last part, as I was saying, that the theoretical part is this one, right? Which has the electromagnetic spectrum, right? So in electromagnetic spectrum, what we have to remember. So first of all, what is electromagnetic spectrum? That we already know that our visible light, right? So all those light like a red, then violet. Red and violet are the extreme colors of our light. So those colors have some wavelength, right? Similarly, Nowadays, we also know that there are different types of rays, like a gamma rays are there, then that X-rays are there, radio waves are there, then microwaves are there, infrared, right? So all those rays you can see here. Okay. So electromagnetic wave includes our normal visible light. That's correct. So light is a small portion, very small portion of your electromagnetic spectrum, right? Which we can see, obviously. So therefore, we call it as a visible light. Then, like the X-rays, we have gamma rays. Right? X-rays, we already know that normally we use it for that bone fracture and everything, right? That X-ray, yes, it is exactly that. Then gamma rays, right? Then we have the radio waves. Radio waves normally we use for the communication purposes, right? Like your whatever mobile data, mobile network, everything, right? So it is in the form of radio waves. Then microwaves, right? In the oven, micro oven we say, right? So micro oven, we use this microwave actually to heat the food. Okay. Then ultraviolet rays, you know that ozone is protecting us from the ultraviolet rays. Infrared rays, so all those combining give us the electromagnetic spectrum. So it is the pattern, right? And you can see this is the pattern, right? So this is the wavelength here and the frequency, right? So here you can see the wavelength and the frequency also. So remember from the top, at least we should know that, at least order we should know that which one has the highest wavelength and everything. Right? Then one more thing that we know that frequency and velocity, right? What is the relation between frequency and velocity? Sorry, frequency, velocity and lambda. V, frequency and lambda. Tell me the relation between these three. So write down somewhere. So velocity is equal to frequency into lambda. Let me see what they have called the frequency as. Frequency symbol is they have used. Frequency. Okay, anyway, so can you use the So frequency is equal to f lambda, right? Or velocity, instead of velocity, I will see the c now here. Now we know that normally we say that c is the speed of light, but all those electromagnetic, as I told you already, light is just a small part of that electromagnetic wave. So whatever electromagnetic wave we have studied, right? So all of them will have the velocity that is 3 into 10 raised to 8. So that is constant, right? So if this c is constant, what I can say, if the lambda changes, lambda increases, let's say, if the lambda increases, frequency will decrease. So it's like that. If the lambda decreases, frequency increases. Okay. You guys know about the lambda and frequency, right? Right. So wavelength, rest, everything. Okay, no problem. Sure. So all these segregation we have done, it's completely based on that frequency and wavelength, right? So you can observe. So first one is a gamma. Gamma is the topmost, then X-ray, then ultraviolet, then our visible. In visible, we have all that pure color, infrared, microwave, and then radio waves, right? So this is how we are going to remember. So you can see the gamma rays, right? So wavelength of the gamma rays is how much? It's 10 into 10 raised to minus 14, right? 10 into 10 raised to minus 14 means, if I draw, let's say this wave, this is our, we know this is wavelength, right? One wavelength. Now, if you measure this, right, how much? I think this could be 1, 2, 3, 3 centimeter or something. This is your 3 centimeter wavelength. Right? Obviously, if I zoom it, it will look bigger, but consider this is a 3 centimeter wavelength. Now, what is the wavelength of the gamma? It is 10 to the minus 14 a meter. So 0.0000 many zeros. So I cannot even draw that wavelength here. That small wavelength is of gamma, right? And once you have the wavelength, you can easily calculate the frequency. I know that C is equal to 3 into 10 raised to 8. Frequency, we don't know, we have to calculate. And this is 10 raised to minus 14 there, see. You can say obviously frequency will be 3 into 10 raised to 22 or something. So approximately, these are approximations. It's not like exactly gamma rays will be 10 raised to minus 14, right? So that's also they have mentioned here actually. There is no sharp divisions of that. So it is approximately 10 raised to minus 14, we can say, right? And the frequency we got for this gamma rays is 10 raised to 22, 10 raised to 23, like this. Okay, so these are the frequencies. So once you know the lambda, we can get the frequency very easily. It's like that. Then X-ray, you can consider X-ray is 10 raised to minus 10. Let's say 3 into 10 raised to 8 is equal to frequency into 10 raised to minus 10. So you'll get the frequency easily. Okay. Right. So no, you don't have to memorize this, but you should at least know the order, that which wavelength is greater or which frequency is greater. Right. And if you can keep some idea about in mind for this light, at least for red color, violet color, yellow color, these 2-3 colors wavelength we should know. Frequency we don't have to worry. As I told you, frequency we can easily calculate, right? Then keep the, not the exact values, but just some idea, we can say just idea that gamma rays will be 10 raised to minus 14 or something. X-ray will be less than that, 10 raised to minus 12, 10 raised to 10, minus 10, right? Then how much is the visible light? So visible light is this one. Normally remember these values. For violet, obviously we have to remember. For red, we have to remember. And for yellow, remember. Right? So violet is the lowest wavelength which we can see, right? So I think this is 700 nanometer. No? The scale should be inverted actually. Oh, no, correct. We are increasing here, right? So wavelength is increasing actually, right? So this is correct. So from violet, blue, green, yellow, wavelengths are increasing, right? Remember in nanometer for the visible light, remember in nanometer, right? So 400 nanometer means 400 into 10 raised to minus 9 violet. Red is 700 nanometer. Yellow is 550 nanometers, right? Approximately. So in between, obviously, you know that WebGear, we know. So that's not a problem. So here we just have to understand whether blue has the higher wavelength or green has the higher wavelength. We don't need the exact value of that. Okay. Similarly, ultraviolet has the higher wavelength or infrared has the higher wavelength. That we need to know, right? So you can see that wavelength is increasing as we are going downward. Wavelength is increasing. So obviously frequency will decrease, right? As we are going downward. So yes, this order we have to remember again. So gamma, again, first gamma, X-ray, ultraviolet, visible, infrared, microwave, radio waves, right? And in radio waves, they have done the 2-3 types again. So obviously long radio waves will be at the bottom because longest we are increasing the wavelength. So after microwave, you can say short radio waves, then television waves, AM waves, right? You don't have to remember all those things. Just remember radio waves, right? So long radio waves will be at the bottom, short wave radio waves will be at the top, right? Means after the microwave. Okay, so it's like that. And similarly, you can see microwave, short radio wave, long radio, right? You can see the long radio waves. Normally we use this for our broadcasting TV signals or mobile signals like that, mobile network. So you can see those values are how much? 10 raised to 4, 10 raised to 5, right? Here also television 10 raised to 1. So mobile networking, we use this 10 raised to 4, 10 raised to 5. So 10 raised to 4 meter, you can see 10 kilometer wavelength. So you can see this crest and trough, this whole thing is 10 kilometer. Even 100 kilometer, 1000 kilometer waves are also there. So these bigger waves are there in that radio wave. So you can see the spectrum covers a very small wave to very large wave, right? So it's like that. So this is a spectrum. So after that, we just have this, you can see radio waves, microwaves, little bit information about all of them, right? And this table will give us some idea. That's it. That will be the end of the chapter, right? So next session we'll just we will do some overlook of all these waves, and we'll move to the next chapter then, right? So whatever questions we have solved, right? Those are the types normally they do ask. About wavelength, they can ask you the simple question. Which wavelength, which will have the more wavelength, like that and like that. That's very easy. Okay, so anyway, so in next session we'll just get some idea about all these waves, and then can move to the next chapter. Okay, so we can stop here for today. Thank you very much, guys. Have a nice day.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.